Hello everyone, this is another video on scattering numericals, and here we'll be solving more questions based on Born approximation and partial wave analysis. So I hope you will understand the numericals that we're going to solve. Okay, I think we have solved like 7 questions. This will be, I think, question number 8. I think, I'm not sure about it. Anyway, write the question. The Born approximation. Use the Born approximation Use the Born approximation to calculate the differential cross section to calculate the differential to calculate the differential cross section for scattering. Calculate differential cross section for scattering by the central potential by the central potential VR is equal to alpha by r square. Okay, where alpha is a constant. Where alpha is a constant. Given the integration is given, that will be used, given 0 to infinity sine x whole divided by x dx is equal to pi by 2. This integration given, this is not usually given in entrance exams. You have to kind of remember this integration. Okay, you have to make a separate note where you'll be writing all the weird integrations like sine x by x dx. Another one we have studied, e to the minus alpha x sine alpha sine q alpha, something like that we had written. So these things you have to kind of remember. Okay. So again, what is asked in the question? Born approximation, calculate differential cross section for scattering by the central potential. This is a central potential. So for central potential, we know the scattering amplitude. There are two types of potential: central potential and general potential. So for central potential, we know the scattering amplitude as what? F of theta is equal to minus 2 mu by h cut square q, right? H cut square q, 0 to infinity r vr sine qr dr. This is the expression for scattering amplitude for central potential. For we have done it again and again. So I hope you remember it by now. Central potential. So what is given? Potential is given alpha by r square. So let's put alpha by r square. So minus 2 mu by h cut square q, 0 to infinity r into alpha by r square sine qr dr. All right. So r got cancelled here. Alpha will go out. So 2 minus 2 mu alpha by h cut square q, 0 to infinity sine qr divided by r dr. So this is the integration. Okay. This is the integration. Okay. And one thing is, this is x is taken as qr. Okay. What is q? Q is your what? 2k sine theta by 2, and x is actually qr. So in place of qr I can put x. So let's take this q inside. Okay. So minus 2 mu alpha h cut square, 0 to infinity sine x. Okay. Sine x divided by x. Okay. Another thing will be, I will take both dx is equal to q dr. So in place of dr I can put what? This is I have substituted this one. Okay. Substitute x is equal to qr to get the integration form. Dr is equal to dx by q. So dx by q. So a q goes out. Eventually q goes out. So mu naught 2 minus 2 mu alpha by h cut square q, 0 to infinity sine x by x dx. So the integration for this one is given here, pi by 2. So I will directly put pi by 2 there. So minus 2 mu alpha by h cut square q into pi by 2. Okay, 2 gets cancelled. So minus mu alpha pi by h cut square q. So this is the expression for scattering amplitude. Alright. But we are asked what? We are asked differential cross section. So that is what? Sigma theta is equal to f of theta whole square. Right? So this is your mu square alpha square pi square divided by h cut fourth q square. So this is the expression, right, for differential cross section. Total cross section we will multiply 4 pi. Alright. Yeah. So this is the first question. I hope you understood. Please write it down. Try to practice these questions again and again, okay, so that you will get a very good hold on this. Done. So we will move to the next question. Question number of the question. Question number 9. Question number 9. So question number 9. Consider scattering by Yukawa potential. This is scattering by Yukawa potential VR. VR is equal to V naught e to the power minus alpha r by r. So we have done it so many times, so you should remember now what is Yukawa potential. Where V naught and alpha are constants. Okay. Okay. In the limit e tends to zero. In the limit e tends to zero, so that the differential scattering cross section scattering cross section is is independent of theta and phi is independent of theta and phi. Consider scattering by Yukawa potential VR is equal to V naught e to the minus alpha r by r, where V naught and alpha are constants. In the limit e tends to 0, so that the differential scattering cross section is independent of theta and phi. Okay. So try this question. I'm giving you 2 minutes. We have done enough questions so that you'll be able to solve this kind of questions on your own now. Please try. Should be able to solve this one. You have to find differential cross section. So remember what is the process. You have to first find the scattering amplitude. Scattering amplitude is always the first thing you need to find. Yukawa potential is which kind of potential? It is a central potential. Okay, remember Yukawa potential is a central potential. So you have to use the formula for central potential. So use the formula of scattering amplitude for central potential, not the general potential. Central potential. Okay, let me solve it. So potential is given. So scattering amplitude f of theta is what? Minus 2 mu by h cut square integration 0 to infinity r vr sine qr dr. Okay. So minus 2 mu by h cut square q, sorry, I missed q 0 to infinity r v naught e to the power minus alpha r by r sine qr dr, right? R got cancelled, the v naught goes out, minus 2 mu v naught by h cut square cube 0 to infinity e to the power minus alpha r sine qr dr. Okay, yeah, we have done this kind of question. We have done exactly this question, I think. Maybe I have repeated it. H cut square cube. And this integration is what? You have to remember. This is q by q square plus alpha square. Okay, directly remember this. So q got cancelled. So what is the final expression? Minus 2 mu v naught by h cut square q square plus alpha square. But what is the question? In the limit e tends to 0, so that differential cross section is independent of theta and phi. Okay. So e tends to 0 means, see, k is what? K is 2, k square is 2me by h cut square. Okay. So when e tends to 0, then k should be tending to 0. Right? K should be 0. Okay. So when k is 0, we know q is equal to what? 2k sine theta by 2. Okay. So when k is 0, then q should be 0. So q is 0 here. So minus 2 mu v naught by, I hope you understood, e tends to 0. So e 2ab by h cut square is k square. So when e tends to 0, k tends to 0. When k tends to 0, then q becomes 0 because q is 2k sine theta by 2. So h cut square alpha square. So this is the f of theta only. Differential cross section sigma theta is what? Square of f of theta square. 4 mu square v naught square h cut fourth alpha 4. Okay, so this is the expression, and this expression devoids of, like, it doesn't have is devoid of theta and phi. It doesn't have theta and phi, so it is independent of. If e was not tending to 0, then this wouldn't have happened and q will be there. And if q was there, then 2k sine theta term will be there. So, like, this sigma would have been proportional to theta in some way. But here, as q is equal to 0, so this theta term totally vanishes. So there is no theta and phi term. Okay. So this difference of cross section is independent of theta and phi. That's what the conclusion is. Alright. I hope you understood. Now you will find these questions really easy. Okay. If you have done them, these previous questions by yourself, write a question. Question number 10. Use Born approximation. Use Born approximation to obtain differential differential scattering cross section to obtain differential scattering cross section when a particle moves in the potential when a particle moves in the potential when a particle moves in the potential, vr, 0 to infinity, 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 is equal to minus V naught e to the power minus R by R naught, where V naught and R naught are positive constants. Okay, are positive constants given. Again, integration is given 0 to infinity x exponential minus alpha x. So this is a sine Vx dx is equal to the value of this integration is given. Again, you have to write it down also in your integration formula notebook. A greater than 0. Okay. So again, potential is given. The integration that you will require in some part of this question is given. So you have to solve it. I'm giving you 2 minutes to try it. It's very easy question. Nothing is there. Please try it. Done. So let's. I hope you could solve it. So let's solve it. Okay, potential is given again. Vr is equal to minus V naught e to the power minus R by R naught. Okay. So again, this is central potential. So we'll directly put f of theta is equal to minus 2 mu by square q. Okay. 0 to infinity R Vr sin qr dr. Alright. So minus 2 mu by square q 0 to infinity r Vr, what is Vr? Minus V naught e to the power minus R by R naught. Okay. Sin qr dr. Alright. So minus V naught goes out, so 2 mu V naught divided by square q 0 to infinity r e to the power minus R by R naught sin qr dr. Okay, see, this expression kind of is similar to this, isn't it? So what is the direct formula? 2ab by a square plus b square. You just have to recognize what is a, what is b. Here, see, this is x, r is x, right? So a is what? A is actually minus 1 by r naught. Sorry. A is your only 1 by r naught, sorry, because minus ax is there. And b is your q, isn't it? Because here this is b, sine q or sine bx. So we'll just put the direct formula 2ab by a square plus b square whole square. So 2 mu v naught by h squared square q. 2ab by a square plus b square whole square, right? So 2 by r naught into q divided by 1 by r naught square plus q square whole square. This is the expression. So 2q by r naught into 1 by, let me write it this way, by r naught square, so r naught square plus q square whole square. Okay, yeah, r naught square can go up, and yeah, we can do one more step here. 4 mu v naught q by h squared square q r naught into r naught fourth divided by 1 plus q square r naught square whole square. So I can cancel the 1 r naught here. Okay. So that will be the expression. So this is only for f of theta. So again, differential cross section will be the square of f of theta. We have done it so many times now. 16 mu naught mu square v naught square q square r naught sixth divided by h fourth q. Oh, this can be cancelled. Okay, very good. 1 plus q square v naught square whole 4. That will be the expression. Okay. Okay, write one homework. You will do this yourself because we have done it so many times now. Number 11. Calculate the scattering amplitude. We'll do this one for practice. Scattering amplitude for a particle moving in a potential Vr is equal to V naught C minus R by R exponential minus R by R. This is the expression. Okay. So where V naught and R naught are constants. So you have to solve it. Okay. Do one thing, do it now. Homework you won't do. So I'm giving you 2 minutes. Again, a simple kind of question to solve it now. Done. Straightforward question, so I'm not going to solve it. We have done so many times. Okay. 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 Let's do one more. This will be a good question. Next is 12. This is a different type of question. Write down. Um, in scattering from a potential, scattering from a potential V R, the wave function psi R, the wave function psi R is written as is written as an incident is written as an incident plane wave plus an outgoing scattering wave, an outgoing scattered wave, sorry, scattered wave, scattered wave psi is equal to e to the power ikz plus f of r. Derive a differential equation, derive a differential equation for f of r in the first Born approximation. Derive a differential equation for f of r in the first Born approximation. Okay, so you have to derive a differential equation including f of r. Okay, so we know this will be solved by Schrodinger equation because wave function is given. So Schrodinger equation is what? Minus h squared square by 2m. 2m we will take it as 2 mu. Okay, del square psi because reduced mass Vr psi is equal to E psi. Okay, so here what is okay? We know k square is what? 2 mu each by h squared square. This is your k square. Okay. So another there is another one ur will be written as 2 mu by h squared square vr. Okay, this is another expression. So let's do one thing. Multiply this one in this side. So del square psi minus 2 mu by h squared square vr psi is equal to minus 2 mu by h squared square e psi. Okay, all right. So this becomes k square, right? This becomes k square. So del square psi minus k square. Sorry, this is your ur. No? Yeah, this is your ur psi is equal to this is your minus k square, right? This is your k square. This is your ur, right? So let's do one thing. Let's alternate the sides. So del square psi plus k square psi is equal to ur. Okay. Yeah. So I can write here that del square plus k square whole psi is equal to ur psi. Psi can be cancelled out. So del square plus k square is equal to ur. Otherwise, no. Sorry, my bad. How can we cancel psi? Okay, psi is this one. So we'll put it here. We need the differential equation including f of r. So we have to put this there. So in place of psi, let's put it. So del square plus k square. Put the value of psi, that is e to the power ikz plus f of r is equal to what? ur e to the power I k z plus f of r. Okay. So now what we have to do, we just have to expand it. Okay. Then we will get the differential del square of e to the power I k z plus f of r. Okay. Plus k square whole into e to the power I k z plus f of r, and in the right side u r, suppose psi. I will put it at the end. Okay. So del square means what? Del square by del x square plus del square by del y square, those things. So here z is there, so del square by del z square. So if I take the double derivative of e to the power I k z, I will get minus k square e to the power I k z, isn't it? Because once I take the derivative, it will be I k e to the power I k z. I will take the derivative again. So this I k will come again. So minus k square, I into I minus 1. Okay, minus k square this one. Plus del square f. Okay, del square f. Alright. Plus this one is k square e to the power I k z plus k square f r. Okay, is equal to u r psi. Alright. So these two can be cancelled out. See, right? These two can be cancelled out. Okay. Mm, so what is left? Okay. What is left? Del square f plus k square f is equal to u r e to the power I k z plus f. Okay. So I can take the del square as from del square plus k square, and f of r is equal to u of this one. Just a second. Not by accident. Oh, okay. So yeah, that will be the expression. Now in place of u r, I can put simply, I can put the value that we had taken earlier, 2 mu by h cut square v r, and this will be your e to the power I k z plus. Okay. So this will be the differential equation including these two. Alright. I hope you understood. Okay. I hope you understood. Okay. So these were some of the questions that we have done. Okay. And now I think you can solve everything that comes your way. Okay. And still, I will take one more class on this. Okay. So that nothing remains. One more class where we will be doing tougher, more tough questions. Okay. These are the basic questions. Um, we have to do more tough questions so that anything that comes our way we can solve. Okay. So yeah, that will be it for today. See you in the next class. Thank you very much.